Hi. So, welcome to the third lecture, which is devoted to Introduction to Probability Theory, during which we are going to discuss different rules for calculating probabilities and interpreting probabilities. And this video is devoted to set notations. So, you're gonna see it's gonna be very useful later on. So, let us start with discussing four sets we are gonna use. Please pay your attention to the fact that typically sets are denoted using figure brackets, and we are going to use this notation as well. So set A consists of numbers 1, 2, 3, 10, 11, 12, and 13. Set B consists of numbers 0, 1, 2, 10, 12, 14, and 15. Set C consists of numbers 3, 11, and 13. And set U consists of all the non-negative numbers, which means positive numbers and 0 as well. And we start with the union. By definition, the union of two sets is a set which contains all the elements belonging to those two sets. So the union of A and B is the set of elements included to both A and B. So pay your attention, this is the symbol we use in order to denote union, and this is graphical representation. So we are discussing all the non-negative numbers, U, that's why A and B are included to set U. So the union of A and B is everything belonging to A, everything belonging to B, and everything belonging to A and B. However, if we go back to the sets, you can notice that there are four elements which belong to both A and B. Those are 1, 2, 10, and 12. That's why when we write the union down for A and B, we do not include them twice. Because in this case, you're going to account for this intersection twice, which is not a right way to denote the union. That's why if there are some elements which are replicated, they belong to both A and B, you include them to the union of A and B, but only one time. Another thing is intersection. So the intersection of A and B is the set of common elements which belong to A and B. So this is the interpretation. As you can see, they have to be the elements of both A and B. And as we discussed before, there are four elements like this: 1, 2, 10, and 12. That's why to the intersection of A and B, we include 1, 2, 10, and 12. And please pay your attention to the fact how we denote the intersection. The complement. So the complement of the set is the set of elements which do not belong to a given set. So the complement of A is the set of elements which do not belong to A. So from the very beginning, we restricted our analysis to the non-negative numbers. That's why we are concentrating on the U only. So this is the graphical interpretation. The complement of A is everything located outside of the set A. Another thing is the empty set, and the empty set is the set containing no elements, literally. So for instance, we can go back to our sets C and B, and when you take a closer look, you will notice that there is no single element which would belong both to set B and set C. That's why when we try to denote the intersection of C and B, we obtain the empty set. And again, this is the graphical representation. There is no intersection of them. They do not contain any common elements. That's why their intersection is just an empty set. as simple as it is. Subset. Subset is a set only containing the elements which also belong to the other bigger set. Again, if we go back to our sets, you could notice that set C contains only the elements which also belong to set A. So those are 3, 11, and 13. That's why we can safely say that C is the subset of A. Again, this is the graphical representation. It is located within A, and in turn, A is the subset of U. So all the elements included to A are also included to U, which is the set consisting of all the non-negative numbers. Okay, I hope it was clear. You will see we are going to use those in the next video devoted to calculating probabilities. And thank you for watching.